Good morning to everyone present here. I'm Sangeeta Lakshmi, working as Assistant Professor in EC Department of RMK College of Engineering and Technology. Today we are going to start the second unit, that is MOSFET amplifier. So what are all the topics we are going to discuss here is, first we are going to see what is amplifier, then we are move on to the load line and Q point. Then we are going to see different biasing methods. Today we are going to see these three topics. So next we are going to see what is load line, Q point in different biasing methods. So we are going to see the two different biasing methods of MOSFET. The first one is biasing with feedback resistor. The first method is biasing with feedback resistor. See here, this is your biasing, that is feedback resistor. This RG is nothing but the feedback resistor. That's why it is called biasing with feedback resistor. Okay. So we know that for the MOSFET you are having the gate, drain, right? Gate, drain as well as source. So the current flowing through the drain terminal is nothing but the ID. Current flowing through the source terminal is nothing but the IS, which is approximately equivalent to ID only. Because the IG current always, I told you in the previous slide, MOSFET, the good quality is high input resistance. Because of the high input resistance, the current flowing through the gate terminal is zero. If it is zero means, what is the meaning? The voltage across RG is zero. Because always the voltage equal to the current flowing through RG is nothing but the IG into RG. IG equal to zero means again the voltage drop across RG also zero. So we can replace this circuit by this circuit because the RG is ineffective from the circuit because of the gate current is zero. Okay, so this is the biasing with feedback resistor. First of all, what is biasing? Biasing means it is a process of giving the DC supply to the transistor in order to operate the MOSFET in a active region or else saturation region or else cutoff region. It is depends upon your application. For example, if you want to use the MOSFET in a amplification purpose, we have to bias the transistor in a saturation region. This is the biggest thing you have to know. BJT always we have to operate in a active or linear region in order to act as an amplifier. But in case of MOSFET, we have to operate this MOSFET in a saturation region for amplification. Okay. Then we are going to see what is load line Q point. So load line is nothing but this is your load line. See this graph. See this graph. In this graph, in x-axis you have the VDS. In x-axis we have VDS. In y-axis we have the drain current ID. Okay. So this is nothing but the transistor output characteristic. That is MOSFET output characteristic. In this dotted line indicates that this is the transition point. That means up to here, this is called a non-saturation region. After this transition point is called saturation region. I told you, if you want to make the MOSFET as an amplifier, we have to operate in a saturation region. So from this point to here, from here to here, this is the saturation region. So out of this whole region, where we have to fix the Q point. Always we have to fix the Q point in the middle of the load line. So this is called as load line. Load line means it is a line drawn on the output characteristic of the transistor. Okay, here it is MOSFET. So this load line will give you where we have saturation region, where we have non-saturation region. Okay. So after finding out this load line, we have to locate the Q point. The Q point will give you the two values, right? Which is nothing but the Q point means we have two values. Always if you have two dimensional, it is two dimensional. In x-axis we have VDS, in y-axis we have the ID. Two dimensional means any point at two dimensional having x as well as y, right? So here also at the Q point we have two values. One is x is nothing but the BDS Q, and y-axis we have the IDQ. Okay, so this point is nothing but the VDSQ, and this point is called as IDQ. Okay, so this is the what is mean by this Q point means, see, whenever if you are applying the DC voltage in order to make it in a saturation region, the VDS as well as the ID current will be established in the circuit. Okay, so that current and voltage is called Q point voltage. Q means quiescent point. Q means it is called as quiescent point. Quiescent, or it is called idle point, or it is called as bias point. Okay, why it is called as idle point means, see, for any analysis, for DC analysis, this is we are analyzing only with respect to DC voltage. Okay, for any DC analysis, we have to open circuit the capacitor, because for DC analysis, you know the reactance of this C1. Reactance XC1 equal to what? 1 by 2 pi FC1. Okay, for DC analysis, we know that frequency equal to 0. If frequency is 0 means you know that 1 by 0 is infinity. That means the C1 capacitor will produces the infinite reactance. Reactance is nothing but the resistance, right? So if it is infinite resistance means this input voltage will not going through the capacitor, right? So we have to open circuit this coupling capacitor C1 as well as coupling capacitor C2, right? Both the capacitor we have to open circuit for the DC analysis. Then only you are getting this circuit. The next circuit you are getting after open circuiting your coupling capacitor, and then you are removing RG because of IG equal to 0. I hope everyone understands this, right? Next we are going to see how to draw this load line. We have seen so far what is load line, what is Q point, right? Next I am going to explain you how to draw the load line. Okay, so for that you have to see this circuit diagram. In the circuit diagram you have to apply the KVL at the output side. So if you are applying the KVL at the output side means what? Output side means in between drain and source. Okay, this side is the output side. So if you are applying the KVL at the output side, see here the current flowing through RD is ID. So the voltage drop across RD is nothing but the what? ID into RD. This is your voltage drop. Next you have the voltage between drain and source is what? VDS. So you have to add this plus VDS. Then it is ground. Ground means 0 voltage, right? Again the circuit will be closing up to here. This VDD is the positive is connected here. The negative is connected to the ground, right? This meaning is the positive of the VDD is connected to the circuit. The negative is connected to the ground. Thereby the circuit will be closed here, right? After this ground, first you are meeting minus. So you have to write here minus VDD equal to 0. Thereby here ID into RD plus VDS equal to VDD. You can consider this is the first equation. Okay. So if you want to draw the load line, we want the 2 points, right? So if you want to draw the load line, see here this is your load line. In x-axis you have the VDS. In y-axis we have the ID. Okay. So here If you want to draw the line means we need 2 points. This is point A, this is point B. We need 2 points. So if you want to locate the point A, you have to apply, see here, if you want to locate this point A, you have to apply VDS equal to 0, right? Yes or no? At point A, the VDS is 0. So if I'm applying VDS equal to 0 in equation 1, you will be getting ID into RD equal to VDD. Thereby, ID equal to VDD by RD. This is your maximum current. This is the maximum current obtained from the source. Right? So, the point A is nothing but the what? VDD by RD, which is nothing but the ID max. Right? So, after locating point A, you have to find the point B. So, how to find the point B means, see, if you want to find the point B, you know that ID is 0, right? So, you have to make ID equal to 0 in equation 1. So, if you are making ID equal to 0 means you will be getting VDS equal to VDD. This is the maximum drain source voltage, right? So, this point is nothing but the what? VDS max, which is equivalent to VDD. So, after locating these 2 points, you have to draw the load line. So, this is your DC load line. So, you have to know, if you want to draw the DC load line, always you have to apply the KVL at the output side, right? You will be getting one equation. In that equation, you have to substitute VDS equal to 0. You will get the point A. Then you have to substitute ID equal to 0 to get the equation, that is point B, right? So, after locating these 2 points, if you are drawing line, that is called DC load line. Clear, everybody? Right? Next, we are see what is Q point, right? See, you have to take the same equation 1, right? From equation 1, you are having ID into RD plus VDS equal to VD. Okay, so here ID is nothing but the IDQ in this equation without substituting any condition VDS equals 0, ID equals 0. Nothing you have to substitute. The same equation, after applying KVL at the output side, you are having one equation, right? In that equation, ID is nothing but the IDQ, which is equivalent to what? VDD minus VDS by RD. So, this is your IDQ. Okay. Similarly, what is VDSQ? VDSQ is, it's nothing but the same equation, VDSQ equal to, you have to write VDD minus ID into RD. Okay. Here, in single equation, you could not able to find out IDQ as well as VDSQ. So, instead of using this equation, we have to use the ID equation, which is nothing but the IDQ equal to, you know that general equation Kn into VGS minus VTN whole square, right? So, if you are using these two equations, you can easily find the Q point value, which is Q point value, right? So, Q point is always located at the center of the DC load line. So, this point is called IDQ. From this current equation, you can able to find out IDQ, right? After finding out the IDQ, if you are using this equation, you will find what is VDSQ. I hope everyone understand this biasing with feedback resistance. Okay.